Assalamu alaikum everyone. I hope you guys are doing good. Right, so in this class, we are going to talk about the third chapter, that is trigonometry. This is basically for P3 maths, it's the A2 maths syllabus. And today we will be talking about 3.2 specifically. It is further trigonometric identities. So let's talk about it. Okay. All right. So basically, again, we have been talking about trigonometric identities in O levels as well, or in AS as well. But here we would not be talking about the basic trigonometric functions. We will be using the advanced trigonometric functions like secant, cosecant, cot, and we would be proving those identities. Okay, all right. So we know we have two basic identities which we need to remember, okay? Or you can think about them as helping identities as well, okay? So we have two helping identities. Number one, tan theta is equal to sine theta over cos theta. This is what we used to do in AS as well. And the second one is, this is the first one. And the second one is sine square theta plus cos square theta is equal to 1. So this is basically the second helping identity. So we will be using these two trigonometric identities in order to solve or in order to prove other trigonometric identities. So let's get started. All right, okay. Let's talk about this now. So example number 1. Okay. Example number 1 basically says that you need to prove tan square theta plus 1 equals secant square theta. Now this basically is the question. In order to simplify any trigonometric identity, you need to know one thing. You can start off with the left side or the right side. Now this is the left side of the inequality, of the identity. And this is the right side of the identity. You can start off with the left hand side and make it look like the right hand side, or you can start off with the right hand side, make it look like the left hand side, or you can simultaneously start both sides and at a point you should prove that both the sides are equal. So it's completely your choice, and this totally depends upon the scenario. For this one, we need to use our helping identity number 2. Let's talk about the solution for this one. Now I know that sine square theta plus cos square theta is equal to 1. This is helping identity 2. It is this one. Okay, I've used this one. And now I need to do something about it just so I get this one. So what I can do is I can divide both sides by cos square theta. So I can just divide both sides by cos square theta, and mathematically that's perfectly fine as long as I'm doing something on both sides. Okay, then I just need to simplify this. I can write it as sine squared theta divided by cos squared theta plus cos squared theta divided by cos squared theta, and it is equal to 1 divided by cos squared theta. So these two can be cancelled and I would get a 1 here. And what is this? I can write this thing as sine theta by cos theta whole power 2 plus 1 equals 1 by cos theta whole power square. Now I certainly know that sine by cos is tan theta and 1 by cos is secant theta. So I can write it as tan square theta plus 1 is equal to secant square theta. Hence, we have proved this identity. This is what we had to prove and it is proved. Okay, so this time around we did not use left side, right side. We just started off by one of the helping identities, and that is how we got the identity proved. So this totally depends upon the question, upon the scenario, whatever it would be. And yes, you guys would be able to do that very, very easily. Okay. The next one is similar to this one, but it's important to practice this. Okay. Now you can also say that this one right here is your, this one right here is your third helping identity, and you'll get to see why I'm saying so. We'll be using this again and again for proving other identities, and this would be given in the data booklet as well. So this is also very important, and we would be using that in the past papers to solve them. Okay. Example number 2. Now you need to prove that 1 plus cot square theta is equal to cosecant square. This is what we need to prove. Okay. Again, we have two sides. Either you can start off by these two sides or something else. Again, I am going to solve this using the second helping identity, that was sine square theta plus cos square theta is equal to 1. Now I have cosecant square here, so I'll divide the entire thing by sine square theta. It's just like the previous one, so you guys would be able to understand it easily if you were able to understand the previous one. And this would become sine square theta divided by sine square theta plus cos square theta divided by sine square theta equals 1 by sine square theta. Now these two can be cancelled. I would get a 1, and this entire thing is basically cot square. So it would become 1 plus cot square theta equals 1 by sine is cosecant. So 1 by sine square would be cosecant square theta. So this is going to be the identity, and this is also considered as helping identity number 4. So we will be using these 4 in order to solve the past paper questions. And obviously third and fourth were also coming from the previous 2. So that is why I wanted to prove those as well. Okay. All right. Okay, let's talk about some difficult questions now. Example number 3 says, prove the identity. Now this is just like, an exam question. It's tan theta plus cot theta square, and it is identical to secant square theta plus cosecant square theta. So this is the left side. This is the right side. We have 4 helping identities. You can start off with any side and then prove it. So I'll start off with this one and I'll make it look like the right hand side. This is the left hand side and this is the right hand side. So let's get started. Okay. Solution. The left hand side is tan theta plus cot theta squared. That is equal to tan square theta plus 2 into tan theta cot theta plus cot square theta. Then I can write down tan square theta as it is plus 2 into tan theta. I can write cot as 1 by tan theta plus cot square theta would come as it is. This and this can be cancelled. And now I am left with tan square theta plus 2 plus cot square theta. One thing is certain, at this point I have tan and cot. In my actual identity, what I need to show is secant and cosecant. So I need to use some helping identities, something that was linking tan and secant. Let's use this one now. So tan square theta plus 1 is equal to secant square theta. This means that tan square theta can be written as secant square theta minus 1 plus 2 plus cot square theta is equal to cosecant square theta minus 1. And this would give me secant square theta plus cosecant square theta minus 2 plus 2. These two would be cancelled. And finally, I have secant square theta plus cosecant square theta. And this was basically the right hand side. Okay, all right. So now we know that the left hand side is equal to the right hand side, and this is how we solve and simplify such questions. Okay, so again, this time around we used the third helping identity and we were easily able to simplify it. Now, one important thing that I would like to explain at this point is some of the students find it one of the most difficult topics. They think that, this question could be uncertain. Like they are certain about other questions if they would be able to do those or not. But this one, they say that it's basically a hit and trial question, stuff like that. If this question is coming for 4 marks, you guys can easily score 2 marks by picking up any side and just start expanding it. For example, I could not do anything about this side, but I could certainly see if I start playing with this one, I started expanding, canceling, stuff like that. So it could be that some of you are clueless at this point, but still you would gain some marks till this step, right? That is important. So you need to do some working that makes sense. And if you are going in the correct direction, certainly you guys would be able to solve it considering the 4 inequalities we have studied. Okay, after this red underlined step, we had tan and cot initially, but we know we need secant and cosecant. So for that, we had to use the third and fourth helping inequality identities, and we were easily able to do this. Okay. All right, let's talk about another question. This is basically about solving an equation. So it says it's basically a past paper question that we need to solve. Okay. All right. It says solve the equation secant square theta plus tan theta minus 1 equals 0 for theta between 0 degrees and 360 degrees. This is basically the interval for theta. Okay, all right. Now this is what we need to solve, and we need to first simplify this and then we would be able to solve it. Now, one thing that I taught in AS as well is whenever you've been asked to solve a trigonometric equation, one thing has to be sure that you only have one trigonometric function. Okay. At this point, I have secant, I have tan, I have two different trigonometric functions. I cannot simplify this. I need to have one trigonometric function and only then I would be able to simplify it. So what I can do is I can convert secant to tan using the helping identity. Here it is. I know that secant square theta is equal to tan square theta plus 1. Okay. So secant square theta can be written as tan square theta plus 1. How? Let's get started with the solution. All right. So the solution. Secant square theta is tan square theta plus 1 plus tan theta minus 1 equals 0. Minus 1 and plus 1 can be cancelled. And now I have tan square theta plus tan theta equals 0. I can take tan common and this is equal to tan theta plus 1 equals 0. And at this point, I can write it as tan theta equals 0 and tan theta plus 1 equals 0. Okay. So this is my interval and we have discussed something similar. How do we play with this? So tan theta is 0 when theta is 0 and if we talk about the graph of tan, we also know that tan is 0 at 180 degrees. So this part was clear and this is coming within this range. This is best. Okay. But if I talk about the second one, this would become tan theta is equal to minus 1. Now tan is negative. For negative tan, we need to talk about those quadrants first. We have 4 quadrants. So it's the first one. Then we have the second quadrant. Then we have the third quadrant. Then we have the fourth quadrant. So it is add sugar to cup. Okay. When is tan negative? Tan is negative in the second quadrant and tan is negative in the fourth quadrant. Okay. First of all, we need to find out the basic angle. So that would be tan inverse 1 and that would give you 45 degrees. This would give me the basic angle, or that is alpha basically. Okay, this would basically be 45 as well, and the angle in the second quadrant would be this one. So it would be 180 minus 45, and that would give you 135. And for the fourth quadrant, it is going to be, this again is going to be 45. And for the fourth quadrant, the angle would starting from here and all the way till here. So it would be 360 minus 45, and it would be 315. Okay. And we know that tan is 0 at 360 as well. So that would also come here. So these three are for tan theta equals 0. And these two are for tan theta equals -1. When it's -1, you need to know it would basically be the second and fourth quadrants for tan, because tan is negative in those quadrants. And this is how we do it. All right. Okay. So this was another question. It was just like a past paper question. Whenever you will come across questions from this part, I would suggest just leave this thing for the end, because I agree this is, this would be done by hit and trial method, but you guys would certainly be able to do these, because you now have your 4 helping identities, 2 with the basic ones and 2 with the advanced angles. You're just supposed to plug in the values according to the scenario, simplify it, play with the quadrants, and then find the theta. The question could be about finding the theta. The question could be about proving the identity. That totally depends upon the examiner. You can certainly have both the questions. And yeah, that is it. So I hope that you guys were able to understand each and everything. If not, then you can just ask me in the comment box, or you can use the link in description box to get yourselves enrolled for our live classes, where we are covering the entire syllabus from the beginning, and where we basically do a good number of past paper questions for every topic. All right, so that is, students, take care of yourselves. I'll see you next time. Allah Hafiz.